So all of these word problems are going to give us a system of equations. And generally what we're going to do is, it's not 100% the case, but a lot of times a sentence will kind of give us one equation. So if you look at this problem here, it says a store is having a sale on walnuts and chocolate chips. And then the next equation says for 3 pounds of walnuts and 2 pounds of chocolate chips, the total cost is $13. So that pink underline is going to make one equation for me. The second one says the next line says for 8 pounds of walnuts and 4 pounds of chocolate chips, the total cost is $33. And then it says find the cost for each pound of walnuts and each pound of chocolate chips. So why don't we call the walnuts X and the chocolate chips Y? Because we don't know how many pounds we have of them. But if you think about when you go into a store, if you buy 3 pounds of walnuts, we know how many pounds, we don't know the cost. So if you go into a store and you buy 3 pounds of walnuts and say they cost $5 a pound, you would spend $15 because 3 times 5 is 15. So that's how we're going to make these equations here. So this first equation, 3 pounds of walnuts and 2 pounds of chocolate chips would be 3 times the cost of the walnuts, so 3x, plus 2 times the cost of the chocolate chips, y, equals 13. And then my second equation would be 8 pounds of walnuts, so 8x, and 4 pounds of chocolate chips, so plus 4y, equals $33. And so now I have this system of equations, and all I have to do is solve my system of equations. If you notice, I'm going to use elimination or the addition method. Remember, we could call it either way. And the reason I'm going to do that is because I don't want to divide any of these. If I start dividing, say, everything here by 3, I get a fraction. If I divide by 2, I get fractions. Same thing here. So what I'm going to actually do is I'm going to multiply this whole entire top equation by -2. And so let's see what I get when I do that. So the -2 has to go to each piece. So -2 times the 3x would be -6x. -2 times the 2y would be -4y. -2 times the 13 is going to give me -26. And then I'm going to keep that second equation the same. So 8x plus 4y equals 33. And now, if I add these two equations together, you'll notice that I have a -4y and a +4y. So that's why I picked a -2, because I saw the 2 here and I said, oh wait, there's a 2 here and there's a 4 down here. If I multiply this top equation by -2, I can make the y parts go away. So that's what I did here. So if I add these together, -6x plus 8y would give me 2x. The y parts would go away. And I have -26 plus 33, and that would give me 7. And so now if I divide both sides by 2, x is going to be 7 halves, or 7 halves is really 3.5. So since we're talking about money, we're going to convert to a decimal. So basically what we're saying is that the x cost $3.50. So x is the walnuts, right? So walnuts are going to cost $3.50. And now I can take this 3.5 on the x and plug it into any equation I want. I'm just going to pick the very first one. So 3x plus 2y equals 13. So we're going to have 3 times 3.5 plus 2y equals 13. So 3.5 times 3 gives us 10.5. So 10.5 plus 2y equals 13. I'm going to subtract 10.5 from both sides. So 2y is going to be equal to, so 13 minus 10.5 is 2.5. And if I divide both of these by 2, y ends up being 1.25. And again, we're talking about money. So we're saying that the chocolate chips cost $1.25. And so now, so basically I just used the problem to come up with that. Pink line gave me the pink equation. The green lines, underlined stuff gave me the green equation. And then I'm just using here what we did before with solving systems of equations. So it's good practice for solving systems of equations if you didn't quite get that before. So let's look at another one here. So it says a party rental company has chairs and tables for rent. And again, the total cost to rent 2 chairs and 5 tables is $35. The total cost to rent 8 chairs and 3 tables is $38. And then just like before, we need to figure out the cost for each chair and each table. So we'll call the chairs X and the tables Y. You can call them any variables you want. So if you wanted to call them, say, C for chairs and T for tables, that would be fine too. So if we write the pink equation, so it says 2 chairs, so that would be 2x, and 5 tables, so plus 5y equals 35. The green equation says 8 chairs, so 8x, and 3 tables, so plus 3y equals 38. So there's my 2 equations. If you notice here, I have an 8 here, and if I just multiply this top equation by 4, then I would have an 8. And since I want one of the variables to drop out, I'll actually multiply it by -4. And again, we're just going to distribute that to each of these pieces here. So we're going to end up with -8x minus 20y equals, so we have to multiply 35 times -4. So -140. And then 8x plus 3y equals 38. So these guys would cancel. So we have minus 17y equals, so -140 plus 38 would give me -102. I'm going to divide both sides by -17. So 102 divided by 17 is 6, so it goes in nice. So 6, so the cost to rent, so y is the table, right? So the tables cost $6 to rent. And again, I'm going to pick any equation I want, so I'll pick that first one, 2x plus 5y equals 35. And I'm going to plug in for the y, so 2x plus 5 times 6 equals 35. So 2x plus 30 equals 35. So I'm going to subtract 30 from both sides. So 2x equals 5. Divide both sides by 2. X equals 250. So the chairs cost $250 to rent. So again, as you go through the problems, you're trying to look to see, how can I make one equation? How can I make another equation? So let's try another one. Ari, the trainer, has 2 solo workout plans that he offers his clients, Plan A and Plan B, and each client does either one or the other, but not both. Okay, so then it says, on Monday, there were 3 clients who did Plan A and 5 who did Plan B. And then it says, on Tuesday, there were 9 clients who did Plan A and 7 who did Plan B. And then it says, Ari trained his Monday clients for a total of 6 hours. So that goes with the pink stuff, right? This time they kind of broke it up over two parts, but it says Ari trained his Monday clients for a total of 6 hours. And he trained his Tuesday clients for a total of 12 hours. How long does each of the workouts plans last for? Okay, so let's make Plan A be X and Plan B be Y. Right? So if I look at the pink stuff, it says 3 clients did A, so that would be 3x, and 5 did plan B, so plus 5y, and he worked a total on Monday for 6 hours. And then if I look at the blue stuff, it says there were 9 clients who did A, so 9x, and 7 who did B, plus 7y, equals 12 hours. And so now again, here I have my system of equations, and I'm just going to get rid of, multiply one of the equations by something to hopefully get rid of stuff. So if I multiply this top equation by -3 and distribute it, I can get rid of the x's. So this gives me -9x minus 15y equals -18. And 9x plus 7y equals 12. If I add these together, the x's go away. -15 plus 7 is -8y. And -18 plus 12 is -6. And so if I divide both of these by -8, right, y is going to end up being 0.75. So you're talking about 0.75 of an hour, right? So if I look for, so it's 0.75 of an hour for B. Now, you would need to look at how the question in Alex, like if this is a question on the test, writing 0.75 of an hour for B is fine. But if it was a question in Alex and Alex asked you for minutes, right, we would need to convert this to minutes. So if you think about it, there's 60 minutes in an hour. So this would be 0.75 times 60. So or 3/4 of an hour, right? So that is going to end up being 45 minutes. And then to find x, we plug back into one of our equations. So 3x plus 5y equals 6. And again, I have to use this 0.75. So 3x plus 5 times 0.75 equals 6. So 0.75 times 5. So I have 3x plus 3.75 equals 6. If I subtract 3.75 from both sides, I have 3x equals, so 6 minus 3.75 is 2.25. And then if I divide all that by 3, x actually ends up being 0.75 as well. So we're going to do 0.75 of an hour for A, which again would be 0.75 times 60 minutes or 45 minutes for A as well. So this one was just a little different, right? Just to kind of show you another way. I think I have one more here. Yeah. Okay, so it says a fruit company delivers its fruit in 2 types of boxes, large and small. Okay, so, and then it says a delivery of 3 large boxes and 5 small boxes has a total weight of 77. And then it also tells you a delivery of 6 large boxes and 2 small boxes has a total weight of 104. So if we call our large boxes X and our small boxes Y, so that first equation is saying, so 3 large boxes, so 3X and 5 small boxes plus 5Y has to equal 77. And then that second line is saying 6 large boxes, so 6X plus 2 small boxes, so plus 2Y equals 104. And so if I multiply this top equation by -2, I can get the x's to drop out. So we're going to multiply it times each of these 3 pieces. So we end up with minus 6x minus 10y equals, so 77 times -2 is -154. And then 6x plus 2y equals 104. And so if I add them together, I have minus 8y equals negative 50. If I divide both sides by negative 8, y is going to be, so negative 50 divided by negative 8 is 6.25. So we're talking about 6.25 kilograms for the small boxes. So the small are 6.25 kilograms. And then again, I'm going to pick any equation to plug it back into. So 3x plus 5y equals 77. So 3x plus 5 times 6.25 equals 77. So 3x plus 5 times 6.25 is going to be 31.25 equals 77. So I'm going to subtract 31.25 from both sides. So I have 3x equals, so 77 minus 31.25 is 45.75. And then if I divide all that by 3, we get 15.25. So the large boxes, because x represented the large boxes, so the large boxes are 15.25 kilograms. So again, in these types of problems, right, you're really trying to look to see, it's almost like a sentence equals a equation, right? Remember on the last problem, it wasn't exactly straightforward like that, but it was pretty close. And so you're basically always trying to set up a system of equations, and then you're trying to just solve the system of equations.